Welcome everybody. This is going to be Earth's revolution, not to be confused with rotation, which was number 86. So this is number 87, and we're going to welcome back Mrs. Marafa again. So now we're going to talk about the other one, which sounds like it, which I wish they would name them like apples and oranges, but they don't. They name it revolution. So revolution is when you move around one object around the other. Now, we can revolve around our sun, but our moon revolves around us.
Right.
A satellite revolves around us. So it doesn't necessarily have to be the sun you're talking about, although if you're talking about Earth, that's what we're talking about.
Okay.
Okay. You want to do this one?
Sure. All planets revolve around the sun.
That's right. So everybody in our solar system, the moons revolve too. And of course the moons revolve around their planets. So you would never want to say the moons revolve around the sun. They don't. They revolve around their planet, who in turn revolve around their sun.
So each planet has their own moon.
Correct.
Or multiple moons.
Multiple moons.
Okay.
Yeah. If you're Jupiter, you have 63 and counting. Oh, all right. So now I'm going to blow your marbles. You ready?
Yep.
Okay. So do we always see one side of the moon? What do you think?
Sometimes I think so.
Yes. Okay. So can you do a diagram with me? All right. Can we stand
Sure.
up?
Yeah.
Okay. So you're going to be the Earth, and I'm going to be the moon. Okay. So we're going to face each other.
Okay.
So now we're going to revolve. Now you have to stay looking at me no matter where I go. Okay. Like this.
Am I turning
Yes.
with you?
You got to turn with me. So this is what the moon does. So we always see the same side, even though you're turning day and night, right? We're going on a night now.
Nighttime.
Okay.
Yep. Yep.
So this is what's called, thank you, a synchronous orbit. Okay. So that means that the moon, you always see the same side.
Okay.
Okay? Just rotation
of the moon.
of the moon.
So the moon rotates at the same speed it orbits. You will always see the same thing.
Okay. But let me ask you a question. So what if I all of a sudden decided to travel to the other side of the Earth? Would I see a different side of the moon?
Say like Shanghai, China.
Sure. Where you went? You went to China.
I went to China. You'd see the exact same side of the moon.
How come you saw the same side of the moon?
Because the moon revolves at the same speed it rotates. So you always see the same side.
Okay. And that diagram was trying to show us on the red.
The red is the side
red
we
was the
always
same side.
see.
Okay. So, but what if we really wanted to see the other side of the moon? What would we need to do?
Well, we'd need to do what we did when we landed on the moon. So we sent a spacecraft up, and the spacecraft went around the moon and saw both sides because it went around the back side or the dark side of the moon. Our moon has a light side, which is the side we see, the sun reflects off of, and it has a dark side, which we never see.
Right. Unless we take a spacecraft up there, that's the only way we could see it.
So Neil Armstrong, when he landed on the moon,
Yeah.
went around the moon a couple of times
Yeah.
when he orbited so he landed on the moon, and they got to see the back of the moon.
So just them.
Just them. And the couple.
So let's talk about revolution times. You want to do that?
Yes.
Okay.
365.25 days.
Let's be
equals
precise.
1 year.
0.25 days. Yeah.
Did not know that. Just thought it was 365 days.
Did you get out of town?
Did not know there was.
All right.
Yep.
Cool. See?
Every 4 years, we add a day.
Yeah. Because we got to make up those 0.25s.
Right.
Yep.
So February 29th is that day.
Yeah, we don't just make up a
Hence
day.
the
It's
leap
always that day.
Correct.
Like they don't go, let's go December 32.
Let's go pick a March date.
Yeah. No, it's always that one.
Okay. The last February 29th was 2012,
Yep.
and the next one will be 2016.
Yep, exactly. So you want to do the fun ones again? Okay.
So,
This is revolution. So
okay.
remember, once around the sun.
Perfect. So Mercury is 87.9 days.
Yeah, which would make sense because it's the closest to the sun, right?
Yep.
So shortest. Okay.
Mars is 686.9 days.
And just think, that's our closest neighbor, and they doubled it, the
Wow.
amount of time. Yeah, so close
Yes, they
is
did.
relatively.
Right,
It's
right.
pretty far away.
Yep. Uranus is 84.01 years.
Years.
Wow.
That's a
very
lifetime, a
slow.
human
Yeah,
lifetime.
yeah. And Pluto is 247.68 years.
So you guys are watching. This is revolution. So this is the path that a planet travels around the sun. And you can see Mercury, who goes much faster than the rest. Remember, our Earth, which is the blue one there, takes 365.25 days to complete a revolution. And the really cool thing about this diagram is that, oops, it's over. Hold on, let's do it again. Is that it shows you how it is in relation to each other. So you can see how fast Mercury goes compared to any of the other ones, like Jupiter. And so this is really cool. So I'm going to leave this up for a few more seconds. Hope you guys enjoy it. Okay.
So you must say what moves in our solar system.
Yep. I'll go get the phone. You finish the video. Okay.
Create a T-chart. You're going to contrast the rotation versus the revolution. And you're going to tell us why do we have a leap year every 4 years.
Yeah, who is it?